Hi, this question says that a charge 5 microcoulomb is placed at a point. What is the work required to carry 1 coulomb of charge once round it in a circle of 12 centimeter radius? So, for that first we have to draw a circle. So, now see, this is a circle. So, in this circle at a point there is a charge 5 microcoulomb. Okay, suppose we consider that at the center O, suppose O is the center of the circle and at that center there is a charge 5 microcoulomb. Okay, and next it is said that the radius of the circle is 12 centimeters. So we know that this is the radius of the circle, that is 12 centimeter. Now the question is that what will be the work done to carry 1 coulomb of charge once round in a circle? That means we have to place another charge at a point on the circumference of the circle. Suppose we consider there is another charge here that is of 1 coulomb. Now the question is that to revolve 1 coulomb of charge around the circle for 1 rotation of 1 coulomb of charge in this circle, around this circle, right? What will be the work done? That is the question. Now see, when 1 coulomb charge is at a point that is on the circumference and it is moving. So 1 coulomb of charge is in circular motion, right? Because when we are rotating 1 coulomb of charge, that means it is in circular motion around the circle. Okay, so in circular motion, what will be the direction of the displacement? Suppose now for the initial position 1 coulomb of charge is at point P. Okay. After that, some time after at point Q, the charge 1 coulomb is placed. Now after some time. Okay. So when the charge is at point P, what will be the direction? The direction of the charge will be tangential to the point at the surface, right? That means it will be the direction of displacement vector. Suppose dr vector. When the charge is at point Q, then again at point Q, tangentially the displacement vector will be directed like this. Okay. So at each and every point the direction is changing and the displacement vector will become tangential to the point. Okay, to the point. So now see, here the value of work done we have to find out. So from the definition of work done, we know that work done is the integration of the force and the displacement, that will be F vector dot dr vector. If we take the dot product, as we know, work done is the scalar quantity. This is the scalar product of two vector quantity. One is force, another one is the displacement vector, right? So this is the integral form to find out the total work done for one full rotation. Now what about this force? There are two charges present at 12 centimeter distance, right? It means there is a force of repulsion or the electrostatic force, the Coulomb force, because both the charges like charges. So we know that like charges repel. So the force, the nature of the electrostatic force here will be repulsive force. And how the force will be directed? The force will be directed radially outward direction, that is F vector, right? Because there is a force of repulsion. That's why the Coulomb force will be directed in this case radially outward. Okay, so radially outward direction. Why? The reason is both are like charges. Both are like charges. Okay, so F dot dr, right? So now you know that what is the angle between force vector and dr vector? See, this is 90 degree. This is radially outward and this is tangential. So the angle between them is 90 degree. So we know F dot dr will be the F dr cos theta, where theta is the angle between these two vectors. So here theta is equal to 90 degree. Theta is the angle between displacement vector and force vector. So it will be F dr cos 90, and we know that cos 90 is equal to 0. It means the work done is 0. So work done will be 0. And this surface will be work like equipotential surface. Equipotential surface. And in equipotential surface, we know from the definition of equipotential surface that on equipotential surface, the potential difference between any 2 points is always 0, as because of we know work done is equal to the charge into potential difference, right? So work done is 0, it means the potential difference must be 0 because charge is non-zero, right? So potential difference also 0, so it will act like equipotential surface. This is very important. So in this question, what will be the work done for one round around the circle? The answer will be 0, right? So work done will be 0, and it will be act like equipotential surface. Okay, so I hope you understand the concept and the solution. Thank you. All the best.